Hey, Algebra 2 honor students, this is Unit 14, Day 9. We are finishing up our trig graphing unit today, which is a little bit more with our applications using some sine and cosine functions to model real-world situations. We're on page 36 in the packet, and we're just going to actually do number 3 real quick. So once we go through number 3, I'll have you try number 4 on your own. But number 3, we're going to come up with an equation to model a situation where we have the shape of a roller coaster at a mathematics amusement park. Boy, I wish there really was one. I would go for sure. It's a sinusoidal graph. And by the way, when it says sinusoidal, it could take on the form of sine or cosine. It doesn't, even though sinusoidal seems like it's implying that it's a sine equation, we know that sine and cosine are just translated versions of one another. So it doesn't have to be that we write the equation with sine, but let's continue reading. The two high points are 133 feet above the ground, so that will be important to me. The beginning and the end are at ground level. So where the roller coaster starts and where it ends, we're on ground level. The horizontal length of the ride is 650 feet. So from start to finish horizontally, they've gone 650 feet. Write a sinusoidal function that gives the height above the ground as a function of the horizontal distance from the starting point. Use the model to estimate to the nearest foot the distance above the ground 3/5 of the way through the ride. Okay, there's a lot going on there. But one thing I want to point out is that there are two high points. The two high points of this are 133 feet above the ground. So if we start setting up some axes here, let's label them appropriately. This is going to be a horizontal distance from where we start. And this is a vertical distance. This is the height above the ground. Okay, so they're both measured in this case in feet, but one's talking about distance above the ground, one's talking about distance from the starting location right here. And if we read a little bit further, it says that the beginning and end are at ground level. So the roller coaster is going to start at ground level. It's going to eventually reach a height of 133 feet. And then it's going to come back down. And then it says there are two of those high points that it reaches by the time we get to 650 feet, which is the total horizontal length. So it's going to repeat that process again. You're going to go up, and then you're going to come back down on the roller coaster. And that distance right there is 650. All right. So here is what one sketch of your roller coaster ride looks like. But in terms of thinking about the graph, since I've graphed two cycles, we really want to base my graph maybe off of what happens by this mark right here. That's how long it took to complete one cycle of this graph, which to me looks like negative cos. It's an upside down cos graph. All right, so how long did it take to get here? Well, if the total ride is 650, then this mark must be 325 feet away from where we started. So that's going to be something that helps me out in the end. All right, before we determine what the amplitude is, it might be nice to determine what the vertical shift is. Because remember that wrap line that comes across this way, that's going to help me as well. So to get the wrap line, it's the lowest and the highest averaged, which is the lowest point is at 0. So 133 divided by 2, the wrap line is at 66.5 feet. So let's start gathering some of the information. The vertical shift is that we moved up 66.5 feet. Additionally, we know that the amplitude, the height from the wrap line up here, is also going to be 66.5, right? So if this started at 0, the nice thing is that it's 66.5 above and below where that wrap line is. And the last key thing that we have to do is, just like we did in the two examples on page 35, we know that the period is 650, but in the equation, we need to plug in the frequency. So what's period again? Period is 2 pi divided by b. So if I set that equal to 650, we get that 2 pi equals 650b, and therefore b is equal to pi over, well, let's see, if I divide by 650, 2 goes in 325 times. Okay, so we've got our value of b, we've got a, we've got the vertical shift. So putting all of these pieces together, and don't forget it's upside down cos, the height above the ground, which it says is h of d, h of d would be negative 66.5 cos, and this would be pi over 325 d plus the vertical shift of 66.5. So the frequency goes there next to d. There's my amplitude. Negate it to make the roller coaster go from bottom to top. Okay, and then add on that vertical shift at the end. So there are a lot of pieces, but hopefully this seems pretty similar to the population example from the other page, and then also the Ferris wheel example. So the last piece of this is figuring out, it says use this model to estimate to the nearest foot the distance above the ground 3/5 of the way through the ride. Okay, so here we are halfway through the ride. If I was 3/5 of the way through the ride, I want to figure out how high up am I when I'm at that distance. So let's first of all figure out what is 3/5 into the ride horizontally. So if we're 3/5 into the ride, it's 3/5 of 650 feet. Okay, so 3/5 of the way there. Let's see, 3/5 of 650 is, we're at 390 feet from the start. Now again, that's a horizontal distance d. 3/5 of the way through, we're at 390. So to figure out what that height is, we're just going to plug in 390 for d, and that's going to give me the height. So therefore, h of 390 would equal negative 66.5 cos of pi over 325 times 390 plus 66.5. Okay, let's see what that is approximately. Okay, got to be in radian mode. If you're going to type in pi over 325 as the frequency, double check that you're in radian mode. So then to type this in, let's do negative 66.5 cos of, we'll do pi divided by, oops, not e, that would be bad. Let's try that again. Cos. Let's do a fancy fraction. Do I have fancy fractions here? I do. Okay. Pi over 325 times 390, close parentheses, plus the 66.5 at the end, and we get that the height is going to be approximately 120 feet, if we double check that there. Okay. So the main part of the process is really about setting up this equation. Might there be some follow-up questions like this one sometimes where you have to then plug into your equation? Sure, and we'll get more practice like that on the homework as well. But I do want to see if you can try this one. At least get a good idea. We're going to go over this next time we're in class, but if you're daring enough, you're given the model already. Okay, this is a question about modeling the tide as a function of the number of hours that have gone by. And tides do go up and down within the ocean. So that might be something that you kind of can picture and visualize there. But see if you can figure out to the nearest hundredth of an hour what the period is. That should be easy just looking at the equation. And then maybe you'll be able to answer the other questions as well. So we'll do that next time we're in class, but if you want to try it, I'd encourage you to do so. That's it for Unit 14. We're going to be wrapping things up and reviewing pretty soon. Have a great rest of your day.